Hello Kedar, I'm audible. Please confirm once, or you can write in the chat box. Okay. Thank you. Let us wait for 5 minutes. Maybe another participant will join, so we'll wait 5 minutes more. Hello? Hello, Kedar, I'm audible? Okay, okay. Now we'll start. I think today is a Raksha Bandhan celebration, so maybe a student will not join. Maybe all students see the class later. So now we'll start. Okay. So the first question is water flow in a 10 centimeter diameter pipe at a velocity 0.7 meter per second. The mass flow rate kg per minute. The mass flow rate you need to calculate in kg per minute of water in the pipe is. So four option is given. So please you just calculate and try to give your answer in the chat box. And let me draw the what is actually question for other participants also if anyone see later. So the question is, here is a pipe diameter, water is flowing this side and the diameter pipe is 10 centimeter. If you will write in meter, that is 0.1 meter. Again, velocity is given 0.7 meter per second. Okay, the mass flow rate you need to calculate m dot. This is a question. So mass flow rate kg per minute you need to calculate. So if you know the formula how you will calculate, then you can calculate very easily. Okay, in between the week 4 content is about the application of conservation of momentum, Bernoulli's equations and application of the Bernoulli's equations. These three major content of 4 week. So please let me see your answer. Okay, please within 1 minute if you just write your answer, otherwise I will show you answer how you will calculate. Okay, your answer is 5 point. Okay, 5.49 I think in second you, but you need to calculate in minutes. Just multiply with just to check your answer with multiply with 60. So it may be you will get the one of the answer. Okay, you are telling option B is correct. Okay, let me check. So here actually the formula is for other student rho or Q, because you know the discharge is Q, area into velocity, but when you will calculate your mass flow rate, you need to multiply your discharge with density, or you can write it is like that rho AV. So how much rho? Water is flowing, so 1000 into area is given pi by 4 into d square 0.1 square into meter per second 0.7. So the answer will come in meter per second, but when you will multiply with 60, then your answer will come in kg per minute. So let me just, yes, option B is correct. Now just you can see here the how you can solve whatever I have explained above, similar thing. The question second is, or such type of question you can expect in your exam, competitive exam as well as your NPTEL exam. Please follow the such type of question. Question number 2, a water jet strikes a stationary vertical plate horizontally at a rate of 6 kg per second with a velocity of 0.35 kilometer per hour. Assume the water stream move in vertical direction after the strike. The force needed in Newton to prevent the plate moving horizontally is. So please try to just similar type of question I have solved in the previous assignment or in the previous class. So please try to solve within 2 minutes, 3 minutes, or you can take 3 minutes also, no problem, because this is a calculative question. So within 3 minutes you please try to give your answer, then I will show you answer or I will explain the concept behind it. So let me show you answer. You are not able to, or I can wait 1 minute more. So here is the similar concept we'll use, the mass flow rate concept, nothing else. Okay. So let us. So here is question is nothing. One plate is, you can assume one plate is here, which is vertically like that. You can assume. And water jet is striking on that. Water jet is striking like that. Right. Or how much force you need to require to prevent moving horizontally. That is, your horizontal velocity need to be 0. Or plate, horizontal velocity of plate need to be 0. So this is the question. And mass flow rate is already given 6 kg per second. So you know already the data of rho and I think water jet. So you know already the rho of water is 1000 and a into velocity is already given. Okay. Assume the water stream move vertically in the direction after a strike. After a strike it is vertically moving. No angle. The force needed. Okay. So here is concept is that whatever the force exerted by jet on the plate, that much force you only required for prevent the plate. So the force applied by jet is equal to force need by your force need to prevent the plate, right? So force applied by jet, how much? So this is the concept. Let me show you a little bit below. I can write here. So how you will calculate the force applied by jet? Rho a v square, because you know already what is force. Force is equal to mass into acceleration. So here mass into velocity by time. So here mass by t, m dot into velocity. M dot you know already, rho a v and again v, rho a v square here. So rho 1000 area, or you know already the rho a v value directly, you know 6, or velocity is given here 35 kilometer per hour. So how you will convert in minute? 35 divided by 3.6 meter per second. So you can put here 35 divided by 3.6. Here you no need to put the square because already rho a v value I have put it 6. So 6 is a 0.6 here. So 35 divided by 0.6. So when we will 30, 6 5s are 30 and rest 50, and 6 8s are 48. Okay, and 6 3s are 18. So you can correct option C. So your option C will be correct. How you will calculate? Here you need, here all explanation is given, or here is assumption is that the mass of the plate is 0. The assumption is that mass of the plate is 0. Remember please. Why we assume this thing? Because data is not given. If data is given, so how you will tackle this? So your force applied by jet equal to, here you can write the weight of plate plus force required to prevent the plate. So this is the concept, but here your 0. Okay, so another student join, Venkat. So let me move ahead on the next question. So Venkat, we have already solved two questions, which is very, very important. First question was your about the mass calculation of mass flow rate. Second question is about how you will prevent a plate when water jet is striking with a velocity of 35 km per hour and mass flow rate is 6 kg per second. Now the third question is about for a perfect incompressible liquid, not gas, following flowing in a continuous stream flowing in a continuous stream, or you can say river, the total energy of a particle remain the same while the particle move from one point to another. Total energy of the particle, total energy, potential energy, काइनेटिक एनर्जी की बात हो रही है यहाँ पे. Potential energy, kinetic energy, or you can say the your pressure head. Okay, all energy will be constant when particle moving from one place to another place. Let's say the stream is like that and one particle is here. When it is moving from here to here, so the energy is constant at both places. If energy is even value is here, let's suppose 10, similarly your E2 value will be 10, because it is the summation of it. Might be chance to the your potential energy may be lower and kinetic will be higher, or pressure will be lower, or another energy will be higher. This is the another thing, but total energy here will be constant. So I need answer from your side, which option will be correct. This statement is called continuity equation, Bernoulli equation, Pascal equation, or Archimedes principle. So I need the answer from your side, please. Okay, so Kedar is telling option B, Bernoulli's equation. Okay, and Venkat, okay, you are also telling option B. That's good. Yes, option B will be correct. This is the Bernoulli's equation, or you can say the Bernoulli's principle. Now moving ahead with the next, here you can see the explanation also. The equation, the Bernoulli equation, essentially state that the total energy per unit mass of fluid particle consisting of pressure energy, kinetic energy, and potential energy remain constant along the streamline in a steady flow of an incompressible and non-viscous fluid, provided there are no energy loss due to the friction or other dissipative process. Okay, but actually the energy loss in the form of friction and other dissipative process. But Bernoulli not considered these things. So you cannot apply for solving a particular problem. Let me. So you cannot apply solving a particular problem with Bernoulli's equation, such practical problem, because the assumption very like your fluid should be non-viscous, so water is not non-viscous. So such type of assumption violating to apply the Bernoulli's equation in practical applications like reverse solution. So we'll use a Navier-Stokes equation. We'll see in the next coming classes. So now moving ahead on the next question. Next question is about the efficiency of hydraulic turbine generator unit is specified 88%. If the generator efficiency is 96%, the turbine efficiency is what is your turbine efficiency. So the efficiency of hydraulic turbine generator unit, it means combined your turbine and generator both are making one system, and your turbine, the efficiency of hydraulic turbine generator unit is 88%, and the generator efficiency, and only we talk about, if we talk about the generator efficiency having the 96% efficiency. So the combined efficiency is 88% and only generator efficiency is 96%. So the turbine efficiency, here is asking your turbine efficiency. Then the turbine efficiency is what? So please try to use your mind in this question, and you please give your answer within 2 minutes or 3 minutes. You can take 3 minutes also. So please just give your answer. Other student, please try to join in the live session, because if you have any doubt you can ask in the live session. Otherwise this video will be uploaded on YouTube channel. So this announcement for the other student who will not join, who have actually not joined in the live session. So now I want to explain or show you the answer of this question. It is actually, what is the answer you can see here. The efficiency of the hydraulic and turbine unit is specified by 88%. So turbine efficiency and into generator efficiency, actually here is the concept is the efficiency of the turbine and generator unit, that is your turbine and generator, is equal to turbine efficiency into generator, or you can write here like that notation, turbine efficiency or turbine or your generator efficiency. So the combined is already given you 88%, and turbine efficiency you need to calculate, and your generator efficiency is given 96%. So your turbine efficiency is nothing but 88 divided by 96. So you will get 0.916. So 0.916. So you can select option A. Option A is correct. Now we'll move ahead on the next question. The next question is very common question. You can expect such type of questions in exam also. Everywhere you can see, because Bernoulli's equation is very famous question for a question setter, especially on BTech level or even diploma level exams like JEE and another AE exam also. So the question, rho P by rho Z plus V square by 2Z plus Z equal to constant along a streamline is valid for steady compressible and frictionless fluid, steady incompressible or frictionless fluid, steady uniform compressible fluid, steady incompressible, unsteady incompressible fluid. So four option is given. Please try to give your answer in the chat box, and I want answer from your side very quickly. Okay, you have already given. So option B you are telling. Okay. So a steady incompressible and frictionless fluid. Okay. So yes, definitely steady incompressible and frictionless fluids. It is correct. So a steady, I want to explain for other student what is actually the meaning of a steady flow. Already I have explained, but little bit I want to explain here. So your, let's suppose any fluid characteristics, let's suppose velocity with respect to time should not be changed at a particular point. At a particular point means here what is this actually in a pipe flow, or you can assume a channel flow. Assume a channel flow. If you are measuring velocity at a particular point at time is equal to let's suppose 8 a.m. So your velocity is 5 meter per second. When you will see again at 8:30, so your velocity should be 5 meter per second. 5 meter per second. That means your flow is steady. Similarly for open channel. Incompressible means the fluid is not compressible like gas. When you will compress any air, let's suppose this is the volume. This is the volume. When you if you want to compress air, you can compress by applying the here pressure. You can compress like that, but incompressible means you cannot compress. And the frictionless, you know already, the here we are talking about non-viscous fluid. Already we have discussed. So viscosity is 0. So acha, when the viscosity will be 0, what will happen in the pipe flow? Let me discuss, because it is also important question. Or let's suppose when the viscosity is present, here the viscosity is present, or I will write the notation. Here is viscosity not. Dynamic viscosity is 0. So when you will draw your velocity diagram, this is the half portion. When you will draw the half portion velocity diagram, due to the no slip condition, here your velocity will be 0. Here your velocity will be 0. And due to your viscosity, this no slip condition, or you can say the here stagnant, whatever your fluid is stagnant here, so this will propagate up to some distance, which will try to reduce the upper layer and upper layer and upper layer due to the viscosity presence. But if viscosity will not present, what will happen here? Your graph will look like that. If your velocity is like that, your graph will uniform, not the such parabolic, you can say, not such. So this is the difference. So you can think more on that, or you can explore through the some book, or you can also explore through the Google. When the fluid is incompressible, what is the effect of velocity diagram? So such type of question you can expect. So now moving ahead on the next question. Okay, here is the list of assumption: the steady flow, ideal fluid, irrotational flow, inviscid or the frictionless fluid, or flow is along a streamline, incompressible fluid. To such type of assumption, Bernoulli is assumed to derive the equations. Bernoulli theorem is applicable for only transitional flows, both laminar and turbulent, only laminar, only turbulent flow. So this is the very basic questions. So you can give your answer. And in this question I will show you the how velocity your velocity diagram in pipe flow or open channel. I can show you also in open channel how vary in laminar and in turbulent. So please try to give your answer. Bernoulli's equation is applicable for only laminar, turbulent. Here laminar and turbulent, how you will identify the flow is laminar or turbulent? This criteria I will also show you here. How you will calculate the friction factor in laminar and turbulent for calculating the loss in pipe. So this thing I will also show you. Actually I will write here for your more clarification on that. So Kedar is telling option B, both laminar and turbulent. Okay. Venkat, what is your, okay, only laminar. Okay. So you both are telling other, you are telling, one student is telling C, another is telling B. Okay, don't worry. So here Bernoulli theorem is applicable for your both laminar and turbulent. You can see here answer. So a velocity diagram how will look like in the case of laminar. So let us suppose here a pipe flow. In laminar flow, your after the fully developed, after the fully developed. I am using here the term after fully developed, your velocity diagram will look like. This is the center line, or I can write here CL. Oh, okay. So it will be look like that. Complete parabolic. So such type of question you can expect. In case of laminar flow, your velocity profiles follow the equation. Which type of equation? Though parabolic, you can already remember, please. Parabolic. Okay. Now in turbulent case, I am talking about here the your Reynolds number is less than or equal to 2000. This is the laminar case. On how you will calculate your Reynolds number or your friction factor, that is your RA by 64 or 64 by RE. Okay, okay, I will clarify on that. Just wait few minutes. Let me first draw the. In case of turbulent, when your RE is greater than equal to 4000 or greater than 4000, so after fully developed, your velocity diagram will look like that. Here is little bit sharp increasing, and then after like that. Here also linear, you can say the, and then after. So this part is parabolic or logarithmic. Okay, remember please, such type of questions you may expect. So another question is Bernoulli's theorem can be derived by integrating the which? Stokes, Newton's third law, Euler theorem, or Gauss law? So please you try to give your answer. Okay, here 64 by RE is okay, no problem. But in case of your turbulent flow, you will use Moody chart. Moody chart. What is Moody chart? You can follow some books or you can search Google on. You can very easily you can see, or you can use the Colebrook-White equations. 1 by root f like that. And this is a graphical representation of the Moody chart is nothing but the graphical representation of your Colebrook-White equation with little bit modification and all. So now Bernoulli's theorem can be derived by integrating which? Stokes, Newton's third law, Euler theorem, or the Gauss theorem. So okay, everyone telling option, or you both are telling the option C. Okay, good, you are going very well. So next question is question 8. A horizontal nozzle having a diameter of 200 mm at inlet and gradually reduced to 100 mm at exit. The water is flowing through a nozzle, density is 1000 kg per meter cube at the rate of 40 liter per second. The gauge pressure at the wide end of the horizontal is 400 kilopascal. What will be the pressure at the narrow end? So neglect all losses, you can assume only, okay, all losses you need to neglect. So please think on that. what are the questions on how you will approach such type of questions. So just think on the about the question number 8. What is the actually what is asking in the questions, then you can think, and you try to draw the questions on your copy, then you can very easily solve this such type of questions. So please within 3-4 minutes you need to try to finish this question. Okay, you are telling C option for question number 8. I think not. For question number 7, you both are telling option C. Okay, for question number 8, please try to solve. Okay, so Venkat is telling option B. Good. Just I will show you. Just wait few minutes, please. I am waiting for the Kedar answer. Because if you are here, you please try to solve. If you are not like other student not joined today, so he will go through the YouTube channel. But when you will sit with the live session, so it will be more impactful than the when you will see the YouTube channel and all. Okay, now I want to show the answer. Just I will explain first what is actually question is telling. Then, yes, please, you can ask. Oh, you don't know YouTube channel name, so you can go. Okay, you actually please. I have the two channel. One basically dedicated for the your PMRF your NPTEL, and another YouTube channel I have regarding my personal YouTube's videos like civil engineering content. So let me just show you. I just I am sharing. Please, you can see. So visible, please. Okay, if you will type these things, OP Moria, PMRF, NPTEL, TA, so you can access all videos. Or I will give link here also. Another YouTube channel. Let me show you just. So are you able to see? Yes, sir. So yeah, engineers only. Those this is my personal channel. You can follow this one also. So let me share the content again. So the question is actually yes. A horizontal nozzle having a diameter of 200 at inlet and gradually reduced to 100 mm at exit. So nozzle is like that. 200 and 100. So this is 200 mm and this is your 100 mm. Okay. So the density is given 1000. Rate your discharge is given 40 liter per second actually. Gauge pressure at a wide end. Here your gauge pressure is given 40 kilopascal. What will be the pressure at the narrow end? So if we consider here section 1, so PG1 you need to calculate your PG2. Pressure gauge at section 2. So here in question there is no the theta is given, so here is given the horizontal nozzle, so you can assume theta is equal to 0, so your Z1 is equal to Z2, that is your datum will be 0 for both. if we assume here. This is your center line. So now I will write the formula P1 by rho z plus V1 square by 2z plus Z1 is will be 0. Let me write first. P2 by rho z plus V2 square by 2z plus Z2. So Z1 Z2 will equal, so it will be 0. So P1 is already given for rho z 1000 into 9.81. You need to calculate V1 and V2. So here area is pi by 4 into 0.1 square. Here area is pi by 4 into 0.2 square. So whatever will come. So this is, and discharge is equal to area into velocity. So you will calculate V1 is equal to discharge by A1 and V2 you will calculate discharge by A2, and you will put here your V1 value and V2 value. Rho z already given, so only one unknown, so you can easily calculate your PT value. So I will actually, I have not calculated today, so I cannot calculate here, so just I want to show you. So this is the whole procedure, you can calculate very easily. So here your V2 will come like 5.09 and V1 will come 1.27 meter per second and your P2 will come this much. So the option 384 kilopascal. So I think option A is correct. Yes. So 384 is coming. Oh no, here is mistake. So 387.84. So you can write here 388. So option A is correct for that. So what was your answer? Okay, Venkat, you are telling option B, you was telling, but option A is correct. You got it? How you will calculate? I think you have some calculation mistake, but concept is, you just recheck your calculation. Yes, now we'll move ahead on the next question. Next question is about, again, Bernoulli's equation. The Bernoulli equation deals with the law of conservation of mass, energy, momentum, or none of the above. So this is the very basic questions. So I want to know from your side. Okay, both are telling option B. Good. Yes, definitely it will be based on the conservation of energy. So now the question number 10. Question 10 is about a pitot tube is used to measure velocity of flow. The static pressure head is 4.5 meter and the stagnation pressure head is 6 meter. The control volume of tube is 0.92. Calculate the velocity of flow. Calculate the velocity of flow. So just please try to calculate, then I will show you the concept or solution part. In between, I want to share my channel ID in the chat box. So after this question I will take 5-minute break. So if you both want to take the break 5 minutes, you can take after this question. So Venkat, I have share YouTube channel ID, so please you can visit also if you are not able to find out. So Kedar is telling option B, right? Option C, 5.2. Okay, I will wait 1-2 minutes more for Venkat response. Yes, please. Okay, okay. You don't have calculator. Okay, okay. So here is a pitot tube is used to measure a velocity of flow. Okay. So first of all, we use pitot tube for measuring the velocity, and the static pressure head. Actually, using the pitot tube, we measure the pressure, or as you can say the stagnant pressure. And with the help of formulas of Bernoulli's principle, we calculate velocity. So the static pressure head is your 5 meter is given, and the stagnant pressure head is 6 meter. So your velocity formula link with, you need to the formula velocity formula with your static pressure and stagnant pressure. So hope you know the formulas. If you not know, then I will show you. So this is the formula. Okay, here is CV is not control volume. Oh, sorry for that. Here CV is the coefficient of velocity. So you need, okay, in question is not explained very, I think in question need to write the full form. Okay, so don't worry. So your velocity is nothing but, the formula is this: velocity is equal to 2 times P stagnant minus P static divided by rho z, only rho. So this formula come through your Bernoulli's equation. P1 by rho z plus V1 square by 2z plus Z1 equal to P2 by rho z plus V2 square by 2z plus Z2. So Z1, Z2 will be constant, so it will be 0. So 1 your P is stagnant. So this will be cancel out. And your at point A, at point a stagnant pressure, if you will consider your P2 will stagnant, so what will happen? Your velocity will be 0. So only one velocity component will be here and two your component of your pressure. So one is static, another is stagnant. So you can very easily, and G all sides. So G will be cancel out from every component. So only you will remain with your pressure and velocity. So this is a formula. And 2 is here, so that's why 2. So hope you got it. What? So this is the next question, and I want to take 5-minute break. So you can also take 5-minute break, or you can read the question and try to solve the questions. So I am audible, please just confirm. Hope I think I am audible. Okay, sure. So the question number 11 is about, let me just read. A large tank open to atmosphere is filled with water to a height of 7 meter from the outlet tap. The tap near the bottom of tank is now open and the water flow out from the smooth and rounded outlet. So there is no losses here. The smooth and rounded means, so whatever the losses due to the roughness, that is not smooth, and the non-rounded, so that is, we neglect these things. So that's why here written the smooth and the rounded. So determine the maximum water velocity at outlet. So V max you need to calculate at outlet. So please try to give your answer. So for such type of question you can use Venkat, you can use your mobile. If you not have a calculator, so using mobile you can also just try to your mobile, or if or online calculator is also available nowadays. Calculator. So you just write on the Google online calculator, you can get. Let me just check. So just I will guide you. Online scientific calculator you can write. Yes, you can get. No problem. Or I think in mobile you're also, the calculator is there. So lots of options is there in degree, radian, everything is there. Or if anyone the gate aspirant, you can use your gate calculator here also. If you will use your gate calculator, it will be available online. So I think it is available gate calculator. Let me check. Gate calculator online. Yes, it is available, please. If anybody want to use the your gate calculator in the live session, or when you will see this video, so you use. So in exam you will very smoothly you can solve your problem. So for question number 11, please try to give your answer. So actually in gate examination, what is the trend actually? The question from your pipe flow is very important for civil engineering, or this Bernoulli's application is also you can expect the your question from Venturi meter, and such type of questions also you can expect. And because these two topic is very important for gate point of view. Okay, now I want to explain. So here a large tank to open in atmosphere. So like that. Tank is here, a large tank in open it atmosphere filled with water up to height. Let us suppose water is filled up to the height of 7 meter from the bottom. 7 meter height of the bottom from the outlet of the tap. Let us suppose here outlet is there. This is the outlet. So from here actually the 7 meter. Now this maybe we can assume 8 meter not given, or we can neglect. No problem. Whatever is given in the question we will follow that thing only. A tap near the bottom of the tank is open. Now we have opened your tap. The water flow out from the smooth and whatever rounded outlet. So maximum velocity at that V max. So for such type of question you will apply Bernoulli's equation. Remember one thing please, your Bernoulli's equation is applicable along a streamline. So let us suppose whatever your fluid particle is here, it is whatever is here, so it is moving with a streamline like that. So this is point 1 and point 2. This is point 2. So you will apply Bernoulli's equation point 1 and point 2. So P1 by rho z plus V1 square by 2z plus Z1 equal to P2 by rho z plus V2 square by 2z plus Z2. So if you will take datum here, so your Z1 value will positive 7 and Z2 will be 0. P1 equal to P2 because P atmospheric and outlet section is also atmospheric. So this term in this term will be cancel out. V1 square, V1 because it's a large tank, so V1 will be 0. V2 you need to calculate. So only remaining what thing? This side 7 and this side V2 square by 2z. So your V2 barabar nothing but root 2z g already 2g or your Z1. Okay, V2 barabar 2 into z into Z1. So 2 into 9.81 into Z1 value is nothing but 7. So when you will calculate, it will come around 20 or 14. So maybe 11 point something. Yes, 11.7. So you can please solve, or you can approach such type of question or using the Bernoulli's and in this way. So yes, please. Okay, in tank actually we have considered, here is your outlet, right? So here is also atmospheric pressure is coming out. Here also your atmospheric pressure, right? So here atmospheric pressure, that is atmosphere open to atmosphere. This outlet is also open to atmosphere. So you have considered P2 at your outlet, just outside of, not inside, just outside, right? Whatever your fluid particle is attached to your atmosphere, or you can say the air, so that particle we have considered for calculation, right? So here atmospheric pressure and here also atmospheric pressure, so it will be equal. Now the next question is, a vertical axis venturimeter a vertical axis venturimeter has an inlet and throat diameter of 150 mm and 75 mm. So vertical, here we are talking about vertical axis venturimeter, and throat diameter is given 150 mm, has an inlet and throat diameter is 150 mm and 75 mm respectively. The throat is located 300 mm above the inlet and the coefficient of discharge is 0.96. A fluid of specific gravity 0.87 flow through a venturimeter at the rate of 0.04 meter cube per second. The pressure difference at inlet and the throat section. So here you need to calculate the pressure difference inlet and throat. So here you will also apply your Bernoulli's, but how you will apply, you need to think. Then I will draw your sections. So Kedar, your doubt is clear, or if you have another doubt? Okay, thank you. So please move ahead with the question number 12. Okay, so let me solve the questions. Question number 12. So the vertical axis venturimeter has an inlet and throat diameter. So vertical axis venturimeter is nothing but this you can draw vertically. So this is a throat area here. This is throat area. Or you can assume this is inlet. So here diameter is given 150 and here diameter is given 75 and your specific gravity of the fluid is given 0.87. So you can write here 870 as a rho kg per meter cube. How you will calculate? Just multiply with the your density. Yes, 1000. So a specific gravity is nothing but your for other student. Let me just discuss. So whatever you have considered the fluid, so that density of your fluid and density of H2O. So here just you will multiply with the density of H2O, you will get the density of fluid. Okay, now we'll move ahead with the questions. And your discharge is given, flow rate is given, Q is given with 0.04 meter cube per second. So this is all about the question diagram. So the pressure difference is talking. So here you can, and the elevation is given also, I think. The throat is located 300 meter above the inlet. So this side is inlet, I think. Okay, so as per the question, we can delete this. So this is your outlet. So here Q is given 0.04 meter cube per second and this is your inlet. So here is dead, so 150 mm, right? So now we will just will draw the 300 meter, oh 300 mm, not meter. So similarly you can apply here Bernoulli's equation at that point and at that point, and you take datum here. This is your datum. So your Z, if you will consider here Z1, so Z1 will be 0 and Z2 will be 0.3 meter because mm is given 300. So similarly you can apply, just I will write and I will after that I will show you the calculation part. So here P1 by rho z plus V1 square by, because discharge is given, so you can calculate very easily V1 and V2, 2z plus Z1 equal to P2 by rho z V2 square by 2z plus Z2. So already you have value the Z2, Z1. Velocity you can calculate because area diameter is given, you can calculate area and using the your velocity and area, using the your discharge and area you can calculate the velocity. Now only remaining thing, pressure at 1 and pressure at 2, and you can calculate very easily because here asking the pressure difference. So your calculation part is like that. So okay, Okay. 38.81. So here is solution is like that. Your discharge is equal to whatever the formula CD A1 A2 divided by root under A1 square minus A2 square root 2ZH. So this is the formula of Venturi meter. So you know already everything. CD you know already, A1 A2 everything you know, only your remaining thing H. So H is the difference in between head, that is a piezometer, inlet and throat. Okay, so your H is equal to P1 by, okay, rho g, and your Z1 P2 by rho g Z2, and your okay, how this is so your discharge is given, everything is given, and your root 2ZH, root H is equal to is this much. Okay, and then after, okay, yes, please, what you are telling? Yes, yes, whatever I have explained above, so you can go with that also, but here actually the explanation is like that. So the head difference in between the, okay, so actually your head is equated with the your pressure at 1 and pressure at 2. I think both will give the same thing because here already calculate. No, no, I think we'll apply here only the Bernoulli's equation because this will derive using the Bernoulli's equation. This thing we can derive. So I think for because in the difference part, if you will see here is velocity is not present. So I think these things, okay, please, you can go with that also. This concept you can also use. And let me just show you in the full view mode. So, okay, I will upload these things also in the your Google form. So you can access this assignment through the Google form or Google Drive. You please try to this solve such this question with this both concepts. So whether you will get some any difference, so please just mail me or you can in the we'll discuss in the next class also. So the next question is question number 13. Water is flowing at a rate of 2 meter cube per second through a tube with a diameter of 1 meter. If the pressure at the point is 40 kilopascal, what is the pressure of water after tube narrow to diameter of 0.5 meter? So when the diameter was this, that is 1 meter, so your discharge was 2 meter cube per second, and pressure at a point was 40 kilonewton, kilopascal. So if you will reduce the diameter like half, so your pressure, how you will impact your pressure, whether it will be it will be definitely decrease because all options are given in decreasing. So how you will calculate? So please think and try to solve this question. Question number 13. I think in previous question your CD is given. So I think for considering your CD value or coefficient of discharge. So I think for considering the coefficient of discharge, we will go through this concept. Okay. So hello, hello. Yes, for considering your CD value, whatever the CD is given 0.96, so we'll go through this concept, not the above concept, because here we cannot consider your CD, coefficient of discharge. But here we can also consider. Why not we can consider? Because for calculating the discharge, whatever we will calculate your discharge is equal to area into velocity. So we will use discharge with the CD concept, that is the 0. I think we cannot use. Yes. Okay, you please, I think, go through this because we'll consider the CD. So you go through this concept, whatever the solution is given. Okay, I will solve with this for the above concept with the considering the CD value. If I will get any difference, I will discuss in the next class. Okay, for time mean, please try to solve this question, question number 13. So hope I think answer is visible. So just I will show you. Okay, option D will be correct for question number 13. So how you will move ahead? Actually, in question is given, just I will draw a pipe is like that, and at a particular point 1, your pressure 1 at a particular point is kilopascal, 40 kilopascal. When your discharge definitely will be same for both case, when diameter is 1, d is equal to 1 meter. The second case is here when your pipe diameter is reduces to 0.5, and discharge will be same. So at the same point your, or we write here 2, at same point what will be your pressure or change pressure. So you will calculate like that. The pressure drop 0.5. Okay, because here the velocity discharge is equal to area into velocity. So area pi by 4 into d square, and here your v discharge. So when you will calculate the relation between v1 and v2, because discharge in both cases is same. So if I write here d1 v1, discharge same, so we can already write here the pi by 4 into d2 square into v2. So here your d1 value is nothing but d1 value is 1 and v1, and d2 value is 0.5 square into v2. So your v1 is equal to nothing but 0.25 v2. So it is nothing but it is v2 is equal to 4 times, or 0.24 you can write 1 by 4. So v2 is nothing but 4 times of v1. So that's why here it is written. So you will use this formula and you will get your pressure drop, and your pressure drop is this 3.8, and at in case of in the second case your pressure will be the initial pressure minus the pressure drop, so you will get 36.2. Okay, we'll move with the next question. Next question is about a two-dimensional water jet. A two-dimensional water jet strike a fixed two-dimensional plate, and split into two streams such that the ratio of discharge is 3, 2 stream. The angle of water jet striking normal to the plate in degrees is. So here theta you need to calculate. So like that, if your plate is okay, please first you try to, then I will try to solve, then I will show you. Just think on that, because once I will explain, then it will be difficult. Okay, 30 degree you are telling. Okay, within 2 minutes please. Okay, we'll see whether it will be 30 or another. So how you will draw the diagram for this question? So one fixed two-dimensional plate you have, you can fix it, and a water jet is striking, the angle between with horizontal is theta. So a water jet is striking on that, and water is splitting in this way, this side and this side. Let us suppose this is Q1 and this is Q2. So the ratio of Q2 and Q1 will be 3. So this side will water will come more and this side will water will go less. So here you need to calculate theta. So similar formula you will use, but here it is angle is given, so you will use the component, that is the whether you will use the sine component or the cos component of your force, whatever the force will require. So the similar concept we will use. So how you will move? So here you can see the diagram, whatever the diagram is given. So if this is from horizontal, the angle between the horizontal of the plate is theta. So this will also your jet and the water is jet and the plate part or whatever the water is splitting. So it will be also theta. So your Q1 and Q2 will be here is given already. Q1 and Q2 will be Q1 plus cos theta by 2 and Q2 will be 1 minus cos theta by 2. So using the similar formula, you can solve very easily. So it will be 30. Yes, definitely it will be 30. So here you can use these things. Okay. So now we'll move with the next question. Question number 15. The question 15 is a 15 centimeter diameter jet of oil is striking a plate moving away from the jet at a 16 meter per second at an angle 45 degree to the normal. Calculate force exerted on the plate in kilonewton when the velocity of jet is 16 meter per second. So please try to give your answer. So Vijay Kumar has joined just. Okay, Vijay, we have solved already lots of questions, but you have joined, so I will show you the from what we have solved. First, you try to solve the question number 15. Please, everyone, try to solve. So please read the question very carefully. Okay, okay, no problem, Vijay. You will see in YouTube channel. Okay. So question 15, you please try to give your answer for question number 15. Okay. Kedar is telling option B. Another student, please also think, if you will read question very carefully, you can give answer. Okay, let me just discuss the concept. So here is a 15 centimeter diameter jet of oil strike a plate moving away from the jet at a speed of 16 meter per second at angle. So here your jet speed, velocity of jet is 16 meter per second, and your plate is also moving 16 meter per second. So both are moving with the 16 meter per second. So here is a force exerted on the plate when the velocity of jet is 16 meter per second. So here your force will be zero, because whatever is your water is moving with same velocity, your plate is also, if plate is here, after 1 second your plate at 16 meter, your jet also on 16 meter. So what will be happen? So force will be zero. So such type of question is very important, because it's just using your mind, or just read carefully, such type of question you can give answer very easily. So this is the, okay, so this is the, I have questions from the previous year your engineering services exam. I think I have 5 to, I think 10 questions I have. So okay, we today we have not much time, so I cannot solve here, but I will, if anybody interested, so this question I will upload it in separate video on YouTube channel. So you please follow the YouTube channel and you will get the solution of these questions. So in time being, yes please. Yes, PDF will be uploaded. You want PDF? Okay, so PDF you can get from here. Every PDF you can get from here. Let me just show you. Let me share the link. You just, okay, I think from NPTEL side, you all people notified by the NPTEL regarding the content and YouTube. So you can access all the PDF from here, whatever I have sent. Just you open and try to just tell me whether it is, are you able to access or not. Yes. Just you please try to. Are you able to access for remaining week, for the week number 1, 2, 3? You are not able to access. Or link I have sent in the chat box. You just see the chat box. Other student, please, you can solve this question. The pressure outside the droplet of water of diameter 0.4 mm is this. What is the pressure within the droplet? Okay, I think we have already reached on the final. Okay, Venkat. Hello. Are you able to access? Okay, okay. So just I will upload week 4 content, so you can for uh, get the 4 content also, week 4 content. So okay, thank you to all of you. We'll meet in the next Monday. Okay, okay, thank you. Bye bye. Good night. Okay, Vijay. Yes, you want to ask something, Vijay? You have raised hand. Yes, very good evening. Yes, please ask. What is your question? Yeah, energy gradient line. Yes. Okay. Yes, yes. Total head will be constant. Yes, yes. Pressure head also. Definitely. Question number one of what week? Week number? Okay. Let me just see the. Please wait, because I have also registered for same course, so I can also access. Let me just see. Fluid mechanics. Okay. So week number 4. So currently I'm unable to access. So what is actually your doubt? The both option is correct, you are telling? Oh, no, no, no. The question is given the line coincident with your free surface. No. This option will not correct, because you are, let me just discuss what you are telling actually. So you are telling, if this is the water flow, right? So you are telling the, if this is a free surface, and you are telling this is a free surface, and as per the option second, this is telling the total gradient line also, right? You are telling this thing. Oh no, not like that. Total gradient line up to this above v square by 2z. So this line represent your total gradient line, this will line represent the total gradient line, and this will represent your hydraulic gradient line. So you please just go through some book so you can very easily get. Okay. Okay, thank you. Okay, thank you. Bye bye. Okay.